So as I said, this is going to capture the screen. It'll be uploaded to YouTube afterwards. So, well, it doesn't matter for today because, oh no, it does matter because if there's 3 people coming next week, then they can see the lesson that they missed. Okay, so have you all got notebooks? Yeah?
Yeah.
Yeah.
Okay. And everybody's Moodle account works?
Yeah.
Yeah, including the new guy, yes. You were there this morning?
Yeah, I was there.
Oh, okay. And your account was made?
Yeah.
Oh, okay, alright.
I think
When
so.
did you register? Yesterday morning?
No, Wednesday.
Oh, okay, so that's why I had your details down. Yeah. Okay, if you can write that down, this is what we'll be looking at first, dimensions and units. Oh, no. No. I don't like that. I don't like that at all. Because I like if you can write everything, and if you miss something, you can always watch the video later and get it. Yeah. Maybe some people know these words. Maybe not. So does anybody know dimension? Dimension. No. New word?
So we're not in three dimensions?
Yes. Usually. Some of us are in different dimensions, but most of us are in 3. Yeah. Well, if I'm being particular, we're really in 4. X, Y, Z, and time. Yeah. That's one meaning of dimension, but in physics it has a different, well, different meaning, a little bit different. Does anyone know? No? Well, that's okay, we'll look at that in a few minutes. And what about unit? I'm sure some of you know unit. What's unit? What's a unit in physics?
Something to measure something.
Yeah, like a measurement. So, what are some examples?
Meter.
Meter is an example, yeah.
Gram.
Huh? Which one?
Gram.
Gram as well, yeah. Things like this. Okay, so anyways. You don't need to write this down. This is just for me. These are the learning outcomes from the lesson. So, there's basically 3 things we want to get covered in this lesson. We want to talk about units, and that's really it. The first lesson, for every physics class, the first lesson is always units. When you go to college, your first lesson will also be units. Just the way it is. So, I'm going to give you lots of, wait. I'm going to give you lots of slides. Maybe you need to write a lot, maybe you need to write a little. It's up to you to decide how much you need to write from this slide. So, for example, like I said, a unit is a reference system to measure a physical quantity. Maybe you want to write the whole sentence, or maybe you just want to write unit to measure quantity. You know, it depends on your English, and it depends on how much you've seen this before. I don't expect you to write everything, I just expect you to write what you need. Okay? So, a unit, I think, who was that? You were saying for measuring. Yeah.
Yeah.
So this is the key idea. A unit is a system for measuring. Length, mass, and time are called dimensions. Now, can you see what the difference is between length, mass, time, and units? So, how do you measure, what do you use to measure length? What unit do we use for length? Centimetre. Can we only use centimetre? Okay.
Inches.
Inches, yeah. What else?
Feet,
Feet, miles, many things, right? So, length is the dimension. The units can be many different units. Like, dimension is the thing you want to measure, like a length, like a mass, like a time. But unit is how you measure it. Can you see the difference between unit and dimension? So, if I said a person's height, is that a unit or a dimension? A height. No, dimension. Because that's what you want to measure, and the unit might be inches or centimetres. You know, if I said the time to come to school, the journey time to come to school, that's a dimension or a unit? That's a dimension. What might the unit be? How do you measure your journey time to school? Do you measure it in seconds? No. Minutes, yeah. Nobody says, oh, well, teacher, it took me 3,600 seconds to get to school, right? So the unit can change, but the dimension doesn't change. Can you see the difference? Yeah? So, for example, the meter is the unit. And what might the meter measure? It would measure length. Other dimensions exist. And you can make them from these three basic dimensions of length, mass, and time. For example, area is length squared. So, I wonder if you know this one. What's volume?
Volumes.
Yeah. What dimension is it?
Oh, it's 3.
Yeah, what's 3 called?
Cube.
Yeah, length cubed. Yeah? The size is called the magnitude. Magnitude means how big it is. So, size and magnitude, same meaning here. So if I said, what is the size? How much? That's called the magnitude of the measurement. So just write what you need. Don't write everything. That will take too long. If you do need to write everything, you can get the video later. Okay, but just the key things you need. Yeah. Okay, are we happy enough with this? Yeah? Did you have chemistry so far?
Yeah.
Yeah. What did you do in your first lesson in chemistry?
We did the wood.
Yeah? Well, did you talk about units yet? No. The structure of the atom, yeah. So you've proton, neutron, electron covered then. Okay, fine, yeah. The units that you usually deal with in chemistry are what? What's a common unit in chemistry?
Moles.
Moles, yeah. Okay, continuing. So we are, well, actually, I should check. Any Americans? Unlikely. No. So you're all using the International System of Units, also called the metric system. Everywhere uses this system except for America.
Oh, and freedom units.
Freedom units. Yeah, they use freedom units over there. Yeah. Well, I think there's 2 countries that don't use this system: America, and there's some other country that doesn't in the Middle East. I think maybe. Do we know? No. Anyways, everywhere else uses these units. In the UK, it's kind of weird that they use both. They use miles, but then they also use kilometers. Officially, they use this system, but practically they still use miles and pounds and feet in this system here. So, there's 7 basic units in this system. And you need to know these 7. And you probably know these 7. The first one is the meter. That's the unit. And what does it measure? It measures the dimension which we call length. So maybe you want to write down meter M measures length L. That's enough to write down. Meter M measures length L. Okay. What's another unit? What else do we have in this system?
Grams.
Seconds, we have grams, or actually officially kilograms. The next one is the kilogram, kg. And what does that measure? Mass, yes. Mass M. Okay, I think someone said the seconds as well. So seconds, S, is the unit, and it measures time t. Well, they're the baby tree. Everybody knows those. Let's go on to now some harder ones. So what else do we have?
Liter.
Hmm?
Liter.
Liter? No. Actually, liter is not part of the base.
Temperature.
Kelvin, yeah, temperature, yeah, Kelvin or Celsius. Anything else? So that's one extra, Kelvin or Celsius for temperature. What else?
Watt.
You're thinking of the electrical ones, yeah, not there yet. Which one? Another unit?
Pressure.
Yeah.
Not pressure, no.
Wait.
Pascals.
Elect.
No. No. So we have the amp,
Oh.
the ampere, amp. But what does the amp measure? If you might remember this from school.
Current.
Is it current?
Current. What letter do we use for current?
I.
Yeah. Electric current, I. Okay. So amp A measures current I. Okay. Next unit. The Kelvin. What does the Kelvin measure? Temperature T, or theta. Okie dokie. Next one. Any ideas? Getting harder now.
Give us a hint.
Which one? A hint? No, no hints.
Oh, okay.
Power.
No. I mean, these are units, but they're not what's called the basic units.
Joules.
No, actually, it's not a basic unit. The next one is the mole. But what does the mole measure?
Atoms.
Yeah.
Particles.
Yeah, so precisely what?
Electrons.
No. We usually use it for atoms, but what are we measuring when we're talking about the atoms?
It's mass.
Say again?
It's mass.
Not quite, nearly, but not quite. You see, the mole is a measurement of what's called amount of substance. So the mole is just a way to count how much you have of something. And the reason it's often used for atoms is because you usually have a lot of atoms. Right, there's only one more basic unit of the 7 left. I would be impressed if anyone knew it, because it's not really one that we use so much. The last unit is called the candela. Has anyone ever heard of that? The candela, CD. Yes, it measures the dimension of what's called luminous intensity, or as you just say, light, how bright something is.
So what are nits?
Hmm?
Nits. Is it similar?
What unit's that? Spell that.
I don't know how to spell it, but you know when people are describing a monitor's light output, they say nits.
Oh, that might be a computer term. Yeah, something to do with the screen.
Yeah.
Yeah, I'd have to check that out. I don't know what it is, but it might have something to do with the resolution or the quality of the color or something like this, you know. I would expect with like a monitor, you don't really care how bright it is, but you might care about how many colors you have available to you and things like this. So I would guess that it has nothing to do with brightness and instead might have to do with, you know, range of colors.
I think
On
it
the
has
palette.
to do with brightness.
Yeah, you think so?
Yeah.
No, we'll look it up later. So, if it's only for monitors, I'd say it's an engineering term.
Yeah.
Okay, you got that? Yeah. Yeah. Okay. So, these are rules which you probably know. Quantities of the same dimension may be compared or equated. So, as an example, you can say something like, whoops, where's my pen? There. 1 meter is smaller than 2 meters. Obviously, that's okay to say. You can say 1 meter is equal to 3 meters minus 2 meters. That's obviously okay. What you can't say is 1 meter is smaller than 2 kilograms. And that's wrong, obviously, okay? Because this is a dimension of length, and this is a dimension of mass. So it's wrong to do that. So quantities of the same dimension may be compared or equated. And also quantities of the same dimension may be added, subtracted, multiplied, or divided. So, you're allowed to say 3 meters minus 2 meters. That's fine. Quantities of different dimension may not be added or subtracted. So you can't say 1 kilogram plus 2 meters equals 3 somethings. Okay? You can't do that, obviously. But what about 1 kilogram, let's say, multiply 2 meters? Can we do that or not? What do you think? Yeah, we can do that. So, quantities of different dimensions may be multiplied or divided. You can do that. Okay. Now, if you knew all that, you don't need to write anything. But if you need to write something down, you should. But I think you probably know at least most of those rules. Yeah? They seem obvious, right? So, let's have a look at some examples. We'll do these together. I just want to know which are valid and which are invalid, which we can do and which we cannot do. So, can we say 5 meters plus 2 meters? Is that okay or not okay?
That's okay.
That's okay. 5 meters is bigger than 2 meters.
Yes.
Yeah, that's okay. 2 hours is bigger than 1 kilogram. No, wrong. X equals 3 kilograms over 2 meters cubed. Yes, that's okay. That's okay. 5 meters plus 2 kilograms is equal to something. No. 5 meters times 2 kilograms.
Yes.
That's okay, actually. What would you say the answer is?
Kilograms per meters? No.
Not quite.
Was it more?
Yeah, what would we say the last one is? 5 meters multiply 2 kilograms.
So that would be.
That would be 10, firstly. 5 times 2. 10 what?
In kilograms. 10 kilometers.
Yeah.
Square kilograms.
Oh no, not as complicated as that. Huh?
10 kilograms per meter.
No.
Just 10 kilograms.
10 kilogram meters. These also multiply. Yeah. That's all. Like if I said to you 2 kilograms multiplied by 3 seconds, that is equal to 6 kilogram seconds. If I said 2 kilograms divided by 3 seconds, that would be 2 over 3 kilograms per second. Divide seconds per second. Yeah. Yeah? Is that okay? Are you sure? Is okay? Yeah? I would like you to add this to your notebook. Just beside each one, write okay or not okay. Just for practice. I think you've got all the answers right. So just write these down just to have in your notes. So first one, okay, okay, not okay, okay, and no, not okay for this guy. He's wrong. And this one is right. Okay, you got all of those? Or you need a minute? We got that? Yeah? Yeah, let's continue. So, what are the dimensions of each of the following? Note that x has dimension of length and m has dimension of mass. That is, the dimension of x is length and the dimension of mass is m. We can use these square brackets to mean dimension if we want. So, I want to do these ones together. We'll work on these together. So, I tell you that dimension x is a length. So, whatever x is measuring a length. And I also tell you that whatever m is measuring a mass. Okay, so the first question is w equals x plus y plus z. I want to know what's the dimension of w. What's w measuring? So what's the dimension of w? What do we think?
Has to be length.
Has to be length, yeah. Why does it have to be length?
Because they're being added.
Yeah, because these are being added, it means they all must be the same. We know that x is measuring length, so y must also measure length, and z must measure length. Therefore, the total is also a length. So w is a length as well. Yeah? Okay, write this down. We'll do the next one now in a minute. Okay, the next one, what's the next one? A equals xy. Okay. A equals xy. This is the same xy as part A. The same xy. The same as in here, I mean. Okay, so what is the dimension of A?
Length squared.
Very good. Length squared. Okay, C. What's C? Okay, I think we're all getting the idea. V equals xyz. Dimension of V? Length cubed. Yeah. And lastly, D. Who knows what that letter is? Yeah, but what's the name of the letter? Which letter is this? This one. Yes? No? Rho, yeah. What language? Greek, yeah. Rho. Rho equals m over v. What's the dimension of rho? And m has dimension of mass. So what's the dimension here? M over?
M over.
Not quite, nearly. Starts with M for sure. What's next? No? It's M per L cubed. Yeah? Yeah? You know, it's like saying m per L cubed, or m slash L cubed. It's like this. Yeah. Some of you look confused. No? Is okay or not okay?
Okay.
Are you sure?
Yeah.
Okay. Well, you should write it down. Okay, you got that? Yeah? Yeah? Right. So, same question again, except this time you can just write, it's all the same, you can just write the answer with the other answer. I want to know what the units are. So, I said the unit for x is meters, and the unit for m is kilograms. Okay, so what's the unit for W? Remember, x is in meters. It has to be meters. So right beside your answer here, unit equal meter. Right, the next one. What's the unit for A?
Meter squared.
Meter squared. Unit for A is meter squared. Good. Unit for the next one? Yeah, unit is meter cubed. And for the last one, what's the unit? Yeah. That's it, yes. Kilogram per meter cubed. The last one is like this. It's kilograms per meter cubed. For the last one, yeah? Is that okay for everybody? Yeah? Okay, let's continue. So that last one was kind of interesting. We probably have seen this in school before. It's called the density. It's mass per unit volume. You've probably seen this formula before. Density is mass over volume. Have you seen this before? Yeah. The dimension is m per L cubed or ml minus 3. And the units is kg per meter cubed, or you can write it as kg m minus 3. This is called density. We shall not use this. We don't really use the forward slash anymore, okay? Please try to write your dimensions like this and your units like this. This is the normal way in this course and most courses to write it. I wonder how many people would write it like this from high school? Yeah? A couple of you, yeah. And how many people were writing it like this in high school? Yeah, okay. Both, okay, good. I want only this way, okay, or only this way. So this is our first definition on the course. Density, represented by rho, is mass per unit volume. That is, density is mass over volume. So you should write this exactly down, this definition. Yeah, it's really important that you get this much, okay? You must have this in your notebook. Okay. You got that? Yeah. So what I want you to see is that although this is something new, we can still use the basic 7 units. So everything in physics can be simplified into the basic 7 units. So this new thing still uses one of the 7 basic units. Whatever you think of, you can always use one of the 7 units. So you might say, well, what about a unit like somebody saying was watt? Yeah, or joule. You can still write them as a basic 7 unit, and we'll see that later. Okay, continue. Yeah. Right, now, litre is not one of the basic 7 units. And we should, if we're ever given a litre, we should write it instead of metre cubed. This question is, what is the density of water if 1 litre is 1 kilogram? And note, 1,000 litres make 1 meter cubed of water. So let's have a look at this example. Let's do this one together. So we'll just write this example down. So I tell you 1,000 litres equals 1 meter cubed. And I also say the mass of 1 litre is equal to 1 kilogram. And my question is, I want the density of water. So let's have a look at the answer there. The first thing we should do is change litres into meter cubed. Or, you know, we could change, yeah, well actually let's just have a look at it. So, density is mass over volume. How much mass do we have? It doesn't really matter. We can decide whatever amount. So, I won't use 1 litre. Instead, I'll imagine I have 1,000 litres. Why is that a good thing for me to do? Why should I imagine I have 1,000 litres? Why is that better? Well, it's bigger, firstly, but why is it more convenient for my calculation?
It's 0 to
Because the zeros come down
Well, many zeros are also useful too. The reason I'm going to imagine I have 1,000 litres is so I know, I can know exactly what the volume is. If I imagine I have 1,000 litres, what's the mass of 1,000 litres? How much is it? The mass, yeah.
1,000.
No, if I have 1,000 litres. You see, if I have 1 litre, it's 1 kilogram. So, yeah, if I have 1,000 litres, I have 1,000 kilograms. Right? 1 litre is 1 kilogram, 1,000 litres is 1,000 kilograms. Yes?
Yeah.
But if I have 1,000 litres, what's the volume? 1 meter cubed. Yes? So, what's my answer? 1,000 kilogram per meter cubed. That's the density of water. Yeah. A simple example to get started. Okay, you have this example? Yeah, continue? Yeah. Right. Now, we can use something called prefixes to make the units bigger or smaller. For example, 1 kilogram is actually 1,000 grams. 1 kilometre is 1,000 meters. And 100 centimeters is 1 meter. So, in this course, the common prefixes we use will be, firstly, giga. How big is giga? Giga is a G, and how many zeros are in giga? Yeah? 9. It's 10 power 9. That's how big a giga is. So you should write that down. Right. What's smaller than giga? What is it? Mega, what letter? M. And how many zeros?
6.
Yeah. Mega 6. Okay. What's the next one? What is it? Yeah? Kilo, what letter?
K. Small.
Small k. How many zeros?
3.
Yeah, 1,000. Now, let's get to the small units, I think. Centai. What letter?
C.
See? What power? 10 power, or nearly 10 power. Oh, not quite, no, nearly. 10 power minus 2, 0.01. Right, what's next? Milli, what letter? How big? It's pretty small. What power? Minus 3. Two more we shall do. Next.
Some letter like U.
It is some letter like you, yeah. What's it called? Micro. What letter? Ah, yeah, but what's it called? It's a Greek letter. It's a Greek letter, and it's a Pokemon. Pokemon number 151. Yeah, I'm sure you know this. You must know this.
In which dicks?
First gen.
Okay.
Was it shaped like?
It
What's
is
its type?
Mew.
Mew.
Psychic type. What power?
-6.
Minus 6. And the last unit. Nano. Letter. What letter is nano? N, yeah. What power?
10 to the minus 9.
-9. That's a nano. You must know these. You must know these for the exam, of course. Okay. You got all of those? You probably have seen these before, right? In fact, there are many more. These are the main ones, but there are many more. There are some which are bigger than this, and there are some which are smaller than this as well. Okay? All right. Next now. So, what I'm about to show you is how to convert units. The way you maybe learned to convert units in high school is probably a way I don't like, okay? So I want you to watch the way I convert this. I want to convert 50 kilometers per hour into meters per second and then miles per hour. So we'll write this down first. First question is convert 50 kilometers per hour to meters per second. Okay, now this is how I want you to convert it. So 50 kilometers per hour, we say equals 50 kilometers per hour. Actually, I'm sorry, I think sometimes we usually just write hour as a H, not a HR, but it doesn't matter. Oh, okay, I'll change it. Just H then. Right. I need to fix that, so. Okay. This is how I like you to convert things. I would like you to think of the kilo as being like a number. So instead of, oh sorry, I lost my 0, didn't I? 50. So instead of thinking as kilometer, I would like you to think of it as 1,000 meters. Think of the K as having a number value. So this would be 50, and this would be times 1,000 times meter over hour. I really want you to think of this as like it's a number. Also, the hour. You can think of the hour as not being 1 hour, but instead of being 3,600 seconds. So that 1 hour is 3,600 seconds. So all that's left to do is to take out our calculator and put this in. And we have the answer as meters per second. Okay, well this is an easy one to start with. Let me get my calculator out too. Where is it? There we go. Oh yeah, do you all have calculators now? Yeah? Not yet. It's in the post. Huh? How long will it take to get here?
I think we might get today.
Really?
Yeah.
Did you like FedEx it or something? Like?
No, I brought it like 3 days ago.
Oh, okay. Right. What do we have here? Does anyone type that in for me? Oh, actually, I can show you here. So, 50 times 1,000 over 3,600. Yeah. Now, in the exam, you must give your answer to 3 significant figures. 3 SF, 3 significant figures. So what would I say the answer is to 3? 13.9. Yeah. 13.9 meters per second. Are we happy with that? Yeah? Okay. Let's do one a little bit harder. The second half here was miles per hour. Now, in our course, you'll never have to do that because we don't use miles, but just for practice, miles per hour. And I tell you, a mile is 1.61 kilometers. Okay, so 50 kilometers per hour, that's equal to 50 kilometers over hours. Now, we're actually happy with this guy because we want hours in the answer. What's the problem? The problem is with this one. We don't want km. What do we want? We want miles. 1.61 km is a mile. So here's the trick. If I change this into 50 over 1.61 km over hour. Why can I do this? Well, it's still balanced, it still cancels, it's still 50, isn't it? But look what I've made on the top. What is this? How big is that? What is that? 1.61 km. It's a mile, isn't it? Yeah? So, I've changed this into 50 over 1.61 miles over hour. In other words, 50 over 1.61 is miles per hour. You see, I put this on the top to make it a mile, but then I must put it on the bottom to keep it balanced. So I can't just put 1.61 on the top, you know. If I have 2 over 3, I could say that's equal to 2 over 3 times 10 and 10. Right? That's the idea here. So I put this 1.61 in here to make miles. But then I put it here at the bottom to keep it balanced. Do you see the trick? Yeah. So 50 over 1.61 is... So what's my answer? 31.1 miles per hour. MPH, as they use in the UK and the US. Are we okay with that? Yeah. Continue? Yeah. Okay, oops. Right, now, here's a slightly harder one. I will give you the answer, but first I want you to try it by yourself to see if you can get the right answer before I show you how to do it. So I want you to change 50 centimeters squared into meters squared. Now don't do the second part, just do the first part. Convert, well actually let's write that convert, convert 50 cm squared into meters squared. See if you can get the right answer. Now, how many of you have an answer? You got an answer yet? Yeah. Okay, a couple of you have answers, good. You look like you're thinking deeply about this. Do you have an answer? You don't have to tell me the answer, just do you have an answer? Okay. So we have 3 people at least with an answer. Right. So, you don't have to tell me your answer, but you can see if you get the same answer as me. Alright? This is how I would like you to do it. So, we start off by saying 50 cm squared. Now, an important thing to note before I continue. It's a little bit strange, but if I was in maths class and I wrote down xy squared, do I mean this or do I mean this? What do you think? Top or bottom?
Top.
Top, right? Because the square is only on the y. However, when I'm talking about units, if I write cm squared, the square is actually on both guys. It's really like this. Okay? Now that will be important. Let's go back. So this 50 cm squared is really like 50 cm in brackets squared, which is really like 50 c squared m squared. But remember, I said to think of the prefix like a number. What number is the c? It's like 0.01. Remember we said c is like 0.01? Squared. M squared. This is 50 times 0.0001 m squared. Right? So what's that? If I was to multiply it out, it would be 0.005 meters squared. Or, if you like, we can write it as 5 times 10 to the minus 3 meters squared. Now, check your answer if you got it right or wrong. So, over here, hey, how did we do? Did we get it right or did we get it wrong? Most people get this wrong. Over here, how did we do? Did we get it right or wrong? Got it right, Jeff? Did you do it like this? No. But I'd like you to do it like this, please. Because when the questions get harder, this is a useful way to do it. Yeah. I suppose if I'm really being fussy in the exam, I should write my answer like this: 5.00 times 10 to the minus 3 meters squared, just so I can show the examiner, look, 1, 2, 3 SF. Okay, continue. So the next one,
Sorry, just a
yeah.
question. Do we use a period or a comma?
we use a period.
Okay.
But I know in some countries they use commas, yeah, but not here. Why do you use comma?
Yeah.
What's your home country?
South Africa.
They use commas there, okay.
Same for me.
Home country?
Spain and Belgium.
I know Spain, yes, they use commas, yes. And Belgium, yes, they use commas as well. No, periods is what we use. Now, in fact, if you use a comma, that's okay in the exam. Tell me, if I asked you to write the word million out as a number, what would you write? 1?
1.00 and then yeah, comma if you have some comma.
And some people might use this.
Yeah.
Who's using this way in their home country? Yeah? With the comma. And the two of you are using this. Yeah? Okay. I have good news for you. Both of you are wrong.
Yeah, you
So-
don't have any commas or periods.
Yeah, nowadays you're not supposed to do either of these. You're supposed to write like this, 1 space 000 space 000. And the reason for that is because some people use dots and commas. We only keep dots and commas to mean decimal, like this. Okay? But if you start using dots and commas for this as well, then it gets very confusing. Okay? So only use this, please, and only use space. Okay? All right. But better still, use this. Better still.
Which one?
10 power.
Oh.
10 power 6 would be best. Okay. Now, let's look at another type of problem. Let's say convert, I don't know, 100. Convert 0.02 meter squared into centimeter squared. Okay, let's do this one together. Wow, this one's harder. What the heck should I do first here? Yeah, what do I do first here? I give you a little hint. Think about the example we did with miles. It might give you a clue. What did we do with miles?
Divided by
Yeah,
cent.
yeah. So, what we should do is put a centi squared here and a centi squared here, meter squared. So now you have 0.02 over 0.01 squared centimeter squared. This is the same as this, and this is the same as that. So we're finished. $200.
Yeah.
200 centimeter squared. Yeah? I like this way of doing these problems. Maybe this is a new way for you. Okay? I tell you which way I really don't like. I really, really don't like the 1 meter is 100 centimeters. So 10 meters, you know, I don't like this way because it gets very difficult when you start talking about centimeters squared, centimeters cubed. You know, you really have to think very hard. Let me show you what I mean. If I said to you, change 1,000 centimeters cubed into meters cubed. I know what you're thinking from high school. You're thinking, let me think, there's 1 million or is it 1 billion centimeters cubed in a meter cubed? It's probably what you're thinking. Whereas the way I'm doing it, all you do is you look at this and say, well, you know, centi is 0.01 and the cubed, yeah. So it's 1000 times 0.01 cubed times meters cubed. And you're finished. You know? So you pretend the prefix is a number. That's the kind of the trick. Okay, are we all right with that? You should write that example down. Yeah? The reason this is important because maybe in the question they give you centimeters, but the formula you must use meters. That's kind of normal, you know. Or maybe the answer is meters, but they say give your answer in centimeters. You know, this is common. Okay, next. A large sphere of radius 2 meters is to be covered in paint of thickness 2 millimeters and density of 0.5 grams per centimeter cubed. How many liters of paint do you need? So I'll just draw the picture before we start. Firstly, what's a sphere? Yeah, what's another word for it?
Ball.
That's it, just a ball, isn't it? So this is a sphere, or a ball. And I tell you the radius is 2 meters. What's the radius? Which part is the radius? From the center to the edge. That's the radius. And I say the radius is 2 meters. Okay. And then what I do is I paint it. I put paint on the outside. So I cover it in paint. And the thickness of the paint, you can't, rats, sorry. The thickness of the paint is, this thickness here is 2 millimeters. So if you can imagine, I don't know, like if I put paint on this, it's only 2 millimeters of paint. It's not a lot, okay? My question is, oh, and I tell you the density of the paint. So the density of the paint is 0.5 gram per centimeter cubed. 0.5 grams per centimeter cubed. And my question is, how many liters of paint do I need? I want the number of liters of paint. Now, before we start, there's a few things we need to know. So what formula do we need to know here? You need to think all the way back to middle school. What formula do I need? Something has pies in it for sure, yeah? Well, firstly, do I need the formula for volume or do I need the formula for area? Yeah, we could actually use volume or area, but let's imagine it's area. So I don't really have anything that's... Well, actually, I suppose no, I could use this dirty rag. I imagine the paint is like wrapped around the ball. So in your mind, you imagine that you unwrap the paint. So it's like a rectangle, but the paint is kind of like wrapped around it. Do you get what I'm saying here? Yeah. So if you unwrap it, then the area here is the area around the ball. Okay. Does anybody know the formula for the area of this shape?
I know the volume one.
You know the volume one. What's the volume one?
3/4 pi.
Yeah? Or cubed, yeah. 4 over 3.
4 over 3.
Yeah. What about the area? Does anyone know? No 2? No 2? Well, there's a 2 somewhere in it, but not at the start. There's a pi r squared in it. We're halfway done. It's 4 pi r squared. I think. Yeah. isn't it? Now you have me doubting myself. Now I'm wondering if it's 2 pi r squared. No, I'm pretty sure it's 4, isn't it? Okay, that's the area. Also, another problem is we're using grams and centimeters here, and we're using millimeters here, right? We should just use one unit. What unit should we use? We should use meters, and we should use kilograms. Yeah? Now, this question is a little tricky, but I want to give you a minute to try. See if you can get the answer. I'll just give you a rough idea of the steps. In the first step, you should change all the units to, kilograms and meters, etc. The second step, you should calculate how much paint you need. So you could work out, I think you should work out the area of the paint and then the volume of the paint. And lastly, then you can change the volume from meters cubed to litres. This is how I think you should try to do this. Okay? I'll give you 2 or 3 minutes. See if you can work this out. How much paint do I need?
Excuse me, can you repeat the question again?
Yeah, I want to know how much paint, how many litres of paint.
The whole question.
That's the only question. How much paint do I need? I'll give you this information. The ball, you can't see. Yeah, there it is. The radius is 2 meters of the ball. There's the ball. Look, there's the ball. And then what I do is I paint it. The paint is 2 millimeters all the way around. And the ball is 2 meters. How much paint do I need? How many litres of paint? How much paint should I buy?
keep the pi or treat it like
Number, please. Yeah.
number.
Yeah.
So
If you want, pi is 3.14159265358979. Did you get that?
Can we use-
It's right there if you don't have it.
We use 3.14.
I would say for the physics exam you should use at least 3.1415 to be at least 1415. Now your calculator should have a pi button on it though. Or are you using your phone or something?
I found it.
Okay, okay. Now, does anyone have an answer? We have answers?
yes,
Got an answer?
0.507689.
Liters or meters cubed?
You said how much the paint is?
Yeah, in liters.
Liters.
Yeah. This answer sounds like meters cubed. You need to change it to liters.
How much should be the weight?
No, liters. You know liter?
Yes.
Yeah. How many liters? And remember, 1,000 liters equals 1 meter cubed. Oh, you all look confused. Maybe we should do the answer now. Does anyone have an answer? No? Okay, let's have a look. Let's have a look. Let's do this together. So, the first thing I'll do, let's just fix the density. It's 0.5, what was it, grams per centimeter cubed. Isn't that it? Yeah? So I think I'll change that into 0.5 grams over cm cubed. Or to be even clearer, 0.5 grams over c cubed m cubed. Yeah? But I don't want grams. What do I want? So k goes here and k goes here. So this will be 0.5 over 1,000 times 0.01 cubed. But I'll keep this and I'll keep this. So this equals 500 kilograms per meter cubed. So that was the first step. You didn't get 500?
No, I did.
Okay. Right, so if I zoom out a bit, that would be like the first thing to do. Next, what we'll do is we'll take our ball, we'll take the paint on it, and we imagine that we unroll it. So it's like this. You get what I'm trying to draw. Whereas this much is 2 millimeters. And this piece here is the A. Yeah, good, which is 4 pi or squared. Isn't that what we said? So that's equal to 4 times pi times 2 squared. But I don't really want this. I want the volume, don't I? So the volume will be 4 times pi times 2 squared times 2 millimeters. How big is 2 millimeters? Well, you could say that's 2 times 10 power minus 3. Yeah? Okay, good. Let's get the answer for that guy. That would be 4 times pi times 4 times 2 times 10 power minus 3. That would be... Now, because I'm not finished, I don't have my answer. I shouldn't say 0.100. I shouldn't say 0.101. Yeah, I should have more than this. I should say 1005 at least. But you can write more if you want. 0.1005 meters cubed. I'm sorry, but to be clear, I only have the 3 for the final answer at the very end. The 3 is for the final answer. Okay? All right. So, so lastly, I'm sorry to tell you this, but I tricked you. You didn't actually need to know this. Do you need to know this? No. No. So I'm very sorry to do this to you, but I tricked you. Yeah. This is what you call, I don't know if you know this word, a distraction. Have you heard of this? I don't know if it's common in your home country, but sometimes here, especially in the English exam, they put something in the question which is the distraction. Make you think it's important, but it's not. Yeah, I'm sorry. It was mean of me, I know. Anyway, to continue. So we need to convert this into litres. So 0.1005 1000 meters, no, sorry. 1 meter cubed. I just changed this into 1 meter cubed. How much is 1 meter cubed? How many litres? 1,000. So it's 0.1005 times 1,000 litres. Yeah? 1 meter cubed is 1,000 litres. So that is 1, 2, 3. It's equal to 101 litres. Isn't it? 101 litres, right? Did I do that right? 1, 2, 3. Yeah. 100.5. Final answer 101. Right? 100.5 litres equals 101 litres. Final answer. Did anybody get 101? Good man.
I have a question.
Yeah.
If you want to know the V of the paint, you can use the V of the big board to...
Yes, exactly. Yeah.
Yes.
But what's interesting is in physics, it's usually done like this. But in maths class, it's usually done like you said, the volume of the big ball, the volume of the small ball, and you minus them. I don't know why, but in physics we do it like this. We kind of imagine it, we unroll it. Whereas in maths, we do it the way you said. I don't think the answer should be very different. Did you get the same answer or a different answer?
I get a different.
How different?
I think you want the weight of the paint, so I minus the at minus 5. And
Okay, yeah.
And I multiple 5 and divide the 5 and it's the same.
Okay, that's fine. Let's just add in one extra part. Let's imagine now I asked you for the mass of the paint. Just imagine I asked you for the mass of the paint. So do we need to know this? Yeah, we do. How can we get the mass? Quite easily. We use this formula. So what does the mass equal? Density multiplied by volume.
It's 5.
Yeah, do we know the density? Yeah, it's 500. Do we know the volume? Yeah, it's 0.1005. So that's 500 times 0.1005. What does that equal? It'd be 1, 2, 502 or something. What is it? Or not 502, sorry, 50.3 kilograms. Oh, who could that be?
Afternoon, Evan. All right, if
Yeah.
I sent you all an email. Did you all receive the email? Just about the English entry test.
When did you send it?
About 10 minutes ago.
They were busily working on this question, so.
Yeah. Confirm you all received? Okay, so it's just about your, okay, you have your timetable as normal that you can access on Moodle, but you don't have EAP or academic skills. You just have to come to these times for your English entry test. So for engineering, you come to Monday, you have a writing exam at 2 o'clock in B302. On Wednesday, you have your reading exam at 2 o'clock. And engineers, on Wednesday, you have your listening exam at 11 o'clock. So other than that, if you see something marked EAP or academic skills, you don't need to go. You only need to come to these classes. For those who haven't taken the entry test for maths, so that's yourself,
Yeah.
okay. So you'll need to take the maths entry test on Wednesday at 3:30. Everyone else has done taking maths entry?
Yeah.
So there are just 2 tests per
Three tests.
3 tests.
Reading, writing and listening. So writing Monday, reading Wednesday, and listening Wednesday.
And just to be clear, you still have your maths and physics classes. Yeah,
and
it's only
and chemistry.
and chemistry. Yeah, it's just the EAP that's.
EAP and academic
Yeah.
skills.
So the whole week is for the test.
Hmm?
The whole week is for the EAP test.
Who will keep it?
Okay, so the whole week is for the EAP test.
Yeah, the whole week. Yeah, the EAP classes are now EAP tests.
Yeah, okay.
EAP classes will start as normal the week after. Are you all interested in going to Culture Night? Do you know what Culture Night is? Yeah. Okay, so this is one event every year that all cultural establishments open their doors for free, so that you can enter without paying a charge. So if any of you are interested in going into Dublin City Centre, it would be a great night. It's called Culture Night, so you can go there. There'll be some teachers going from the college at 4 o'clock, so I can meet at the gates of the college at 4 o'clock. There'll be people walking into town, so if you're interested.
So just to sell this to you, a lot of places charge for entry. You know, like what's the Wax Museum is an
Wax
expensive one, and there's something else.
Guinness,
Yeah.
Guinness
But they will be free for one night only tomorrow night.
Tonight.
Oh, tonight, sorry. So this is your chance to see things for free, because if you want to go on these places for the rest of the year, you have to pay. The Wax Museum's expensive. It's what, 20? 20, but it'll be free tonight. You know, and Guinness, how much is that? 15?
15.
Yeah, and again, it's free tonight. So a lot of sites are free. This is your chance to save a lot of money if you want to see things.
Like for some, like the Guinness, don't you have to pre-book?
Do you have to pre-book Guinness?
I don't think so, but you might have to queue. That'll be one,
Yeah.
that'll be one
Yeah.
of the more popular ones.
Yeah, at the Wax Museum as well, there's always a big queue outside for people to get in.
What about the Jameson is
Again, there's probably
okay.
have to queue.
Yeah, but it's free is free.
Okay.
Yeah.
So have a good weekend, Leonard. Okay, I'll see you all next week. Thanks, bye.
Okay, did you write that one down?
No,
Yeah.
because Call of Duty Modern Warfare beta tested tonight.
Beta test starts tonight.
Yes.
And you're signed up?
Yesterday evening.
Okay. So I know what you're doing this weekend.
Yes.
You're beta testing Call of Duty.
Yes.
You can report on Monday how it was, okay? You can let us know.
Oh yeah, I will.
Which one is this now?
Modern Warfare.
Modern Warfare.
And the story will
Refresh.
be
Yeah, like a sequel or a reboot?
We'll call it 4-year refresh.
A reboot or a sequel?
and not a reboot.
It's a new one.
It's a rewrite of the story, and Captain Price stop and
Yeah, but it's an old game that's being remade.
Yeah.
Yeah.
not remade, but
Different story?
Different
Yeah.
story.
Okay, so it's a new game then.
The same people, different story.
Okay, so it's a sequel.
Yeah.
That's what we say. Okay, good. Well, you can tell us on Monday then how many hours you wasted on this then. 10 hours? 20 hours?
1 year because Back Ops 4 is totally shit.
You were waiting 1 year for this. Okay, well, I hope it doesn't disappoint you. I hope it's everything you dreamed for. Okay, now, let's just, can you open up Moodle, please, on your phone? Moodle. Yeah, like I showed you this morning, Moodle. DIFC Moodle. Because I think that was the last example. Yeah. Okay, if we can just go to Moodle. Whoops. Wow. And go to your physics page, obviously. You should all have a physics page, right?
Yeah.
On Moodle, when you log in, you should have a page called physics down the bottom. Are you all on the physics page?
Yeah.
Should look like this. Starts off with mechanics. Yeah, you have that page?
Yeah.
Now, if you go down to a section called Books and Resources near the bottom, you all have this link, first link called the workbook. Now, this is the new workbook I'm working on, where all the questions are from exam papers. So 100% of these questions in your new workbook are from exam papers. So, for example, if I click workbook, I should load this. This is coming from my personal server at home. I have a Raspberry Pi computer as my server. I can tell you where it is. It's right beside the telephone at the front door. This is what you're connecting to right now. So if we all connect at the same time, we might crash it. But if we loaded it, did we all load it? Yeah? You all have this? So what I've done for your first homework, dimensions and units, there are, what have we got? 1, 2, 3 questions only. So you can see question 3, we have to convert. Can you see that? And can you see how question 1 and 2 is like my example with the paint?
Yes.
So you can see in number 2, it's about a pipe. And you can see in the picture here how they tell you to imagine. Can you see? Imagine how the pipe is unrolled to make a flat piece of metal. Can you see that? Yeah? So, if you look at the first question, I give you where it comes from. The second question, I give you where it comes from. And the third question, I give you where it comes from. Also, I give you a note. I think the answer is wrong in the marking scheme. So, when you drew these 3 questions, you can go back. So, it's, for example, Physics 18-19, Semester 1, Version 3, Section A, Question 1. If you go back to the Moodle page, you can see that you could go to the exam and you can check and you can get the answer. Okay, but I don't want you to check the answer yet. I want you to try these 3 questions. So these 3 questions are for your homework. We still have about 7 minutes left. So I would like you to start these 3 questions. If you get these questions finished now, then no homework. But if you don't finish them, then I expect you to finish them at home. Okay? So usually what I do, we have a double class, so that's 2 15 minutes class. Now because we didn't take a break in the middle, we'll finish at in 5 minutes. Okay? So try your best. See how much you can do now. Those 3 questions, okay? You can start them now. You all have these open? Yeah? You all have this open on your phone? Yeah? Okay.